2.1 Protection and Safety.
In this lesson, we're going to talk about the most important part of your job, safety. Your primary responsibility is to ensure the personal safety of yourself and your coworkers around electronic equipment. Anytime you work around a computer or any electrical device, remove jewelry to prevent it from getting caught in your equipment or from transferring an electrical charge to your body. Be certain that the grounding pin of the 110-volt plug is intact. Power that comes from the wall is AC, or alternating current. It comes through at between 110 and 120 volts at 60 cycles per second. An alternating current coming out of a wall socket can be enough to stop your heart. Never work on a device until you've powered it down and unplugged it from the wall. If you're working on a portable computer, you must first make sure that the battery is removed from the system. A capacitor's ability to store a charge raises a safety concern that other electrical components don't share. Power coming out of a wall is stored in a capacitor in the power supply unit. Even after the power supply unit is unplugged from the wall, a capacitor can hold on to a charge for up to whole seconds instead of milliseconds. Now, it's important to use caution when working with the power supply. If you're not a trained technician, consider the power supply a field replaceable unit, or FRU. Do not service it, just replace it with a new one. Another good rule of thumb is to avoid servicing anything with high voltage. Do not wear an ESD wrist strap around high voltage. If you are grounded, you become the path of least resistance for the current. And if the current is high voltage, you are the path through which the high voltage current will flow. Some peripherals can present a safety hazard to you. First, laser printers. Some laser printers use laser light that can damage your eyes. They also use toner, which is toxic if inhaled. The toner is fused or melted onto the paper by fuser rollers. During the process, the fuser rollers get very hot and are definitely a safety hazard. The parts of a laser printer that manage the paper path can be complicated and fast, which presents another safety hazard within a laser printer. Second, impact dot matrix printers can present a hazard because the solenoids, the little coils in the print head, get very hot enough to burn you. Third, DVD and CD drives write data with laser light that can damage your eyes. Fiber optic cables also use light that can damage your eyes. Never look down the end of a fiber optic cable. Shine the light into your hand or look for a red dot. Do not look into the cable. Another safety consideration is thermal radiation or heat. Devices inside a computer generate heat, in particular the CPU and memory. Allow a system to cool down before you work on it because some components can get hot enough to cause a severe burn. Any device that has a heat sink or a heat spreader in it should tell you to let that device cool down before you touch it. These devices present a definite safety hazard. Your physical surroundings are another component of safety. Arrange the room in which you work to eliminate physical hazards. Use proper cable management and don't leave wires on the floor. Don't leave components in places where coworkers can trip over them. And be aware of personal safety for yourself and those around you. You can also ensure your personal safety by lifting with your legs, not with your back. If you're lifting extremely heavy pieces of equipment, wear a back brace, use a cart, or ask for help. Every room in which you work should be fire suppressed. At a minimum, you should have a Class C fire extinguisher available to you. Class C fire extinguishers are made for electrical fires. Any component that presents a potential hazard ships with its own MSDS, or Material Safety Data Sheet. An MSDS explains, among other things, what you should do if you come in contact with an electrical component that's potentially dangerous to you. An MSDS also explains how to properly dispose of equipment. For example, an alkaline battery can be disposed of in the trash, and NiCad battery cannot. In this lesson, we talked about safety. Safety is your #1 priority. Anytime you see a hazardous situation that falls within your responsibility, then you should fix it. If it does not fall within your responsibility, then report it to your safety officer and have it taken care of.
2.1.2 Safety measures. Power handling. The following practices should be followed to ensure your safety when handling power components. Hazards description. Power hazards can cause electrical shock and burns. Before handling a system component, make sure that it is powered off and that the main power cord is unplugged from the wall socket. Ensure that the grounding pin on a PC power plug is intact. Unplug the system before working on internal components. Newer power supplies. Power constantly pull power from the socket. Be aware that the power inverter, power supply, converts AC to DC. Also be aware that the power supply can retain an electrical charge, even when it's not plugged in. Replace faulty power supplies instead of trying to repair them. Avoid opening the power supply, which houses a capacitor, stores a large charge of electricity. A capacitor is a device that stores an electric charge. Be sure to discharge capacitors or turn the equipment over to qualified personnel for servicing. Similarly, exercise caution when working with the DC converter in a laptop display. Electrostatic discharge, ESD, is the flow of electricity from one electrically charged object to another. While some ESD can be unnoticeable to the human senses, it can still be hazardous to computer components. Take the following precautions when handling electronics, ESD and use ESD wrist straps not only to protect components, but to reduce the chance of high accidental electrical shock. Properly ground yourself before working with voltage components. Do not use an ESD wrist strap when working with monitors, power supplies, laptop LCD panels, or other high-voltage components. Exercise caution when wearing jewelry, because it readily conducts electricity and could cause burns or even electrocution. Peripherals. A peripheral is a device that connects to a computer, such as a monitor or a printer. Peripherals can present a safety hazard to you. Do not use a regular multimeter or other electrical testing equipment to measure charge inside a monitor. Never clean the monitor's glass with a liquid solvent while the monitor is powered on. Some studies suggest that laser printers emit tiny particles which could be dangerous when inhaled. As a precaution, do not locate laser printers immediately next to desks, and keep the area ventilated. Avoid handling leaky batteries. The leaking electrolytes can be harmful if they get into your eyes. Never look into the end of a fiber optic networking cable. Laser light can damage your eyes. Personal safety. Personal safety is your top priority when working with computer components. The following practices should be followed to ensure your safety. Practice description. Thermal components such as the CPU heatsink and fan, the printing head of a dot matrix printer, or components inside a laser printer can be hot. After turning off a computer or printer, allow components to cool sufficiently before servicing to prevent burns. Physical. Make sure the room and the building are properly set up to ensure your safety. Keep work areas and floors clear of clutter to help prevent accidents. Do not route cables across the floor in pathways. This can lead to tripping accidents and could also result in worn cables. Provide adequate ventilation in an enclosure to remove toxic fumes. Protect yourself from airborne particles by using an air filter mask. Wear safety goggles. Replace worn or frayed power cords. Lifting: be careful when lifting heavy objects. Bend your knees and keep your back straight, using your legs to lift objects. Wear a back brace for added protection if your job requires frequent lifting. Use carts and other tools when moving heavy objects for any significant distance. Ask for help, if necessary, when lifting or moving heavier objects. Follow the weight limitation guidelines defined by your employer. Cleanliness: clean hardware regularly to avoid problems caused by built-up dust. Use compressed air to clean delicate components. Use a specialized vacuum to clean dust from other hardware. Avoid blowing dust into other hardware or all over your office. Every room in which you work should be fire suppressed. Have at least a Class C fire extinguisher available. A Class C fire extinguisher is made for electrical fires. Make sure fire extinguishers and fire suppression methods, example sprinklers, are properly implemented and maintained. Promptly report any potentially hazardous situations. Make the safety of others your top priority in responding to any incident. In the event of a hazardous situation, clear people from the area or remove the danger before attempting other actions such as preventing or repairing damage to components. Clothing and jewelry: jewelry and clothing can get in the way and can help to create or conduct static electricity. Avoid wearing loose clothing. Remove jewelry from hands and wrists when working on computer components. Eyes and mouth: protect your eyes and mouth from flying debris, dust, or allergens by using air filtration mask, safety glasses, material safety data sheet, MSDS. A material safety data sheet, MSDS, provides information related to potential hazards and safety precautions within an organization. A MSDS should include a listing of hazardous chemicals or components. Potential effects of exposure. Requirements for the handling and storage of hazardous materials, including such things as proper battery disposal, proper toner disposal, proper disposal of other devices and assets, response plan if accidents do occur. Plan for responding to injuries. Plan for securing hazardous materials.
In this lesson, we're going to talk about electrostatic discharge, or ESD. As a PC technician, ESD is your worst enemy. You need to know what it is and how to mitigate its effects. A static charge is created whenever two objects come into contact with each other and then are separated. When the objects separate, one of the objects can steal electrons from the other object, which makes the first object negatively charged. The object that lost electrons becomes positively charged. The two objects now have different charge levels. An electrostatic discharge occurs when the two objects with the different charge levels come together. If one object that has a high positive charge comes into contact with another object that has a high negative charge, the charge from the object with the higher electrical potential flows or jumps to the object with the lower potential. The result is an electrostatic shock. As a technician, you need to understand that a computer component, such as a memory chip or a CPU, can be damaged by an electrostatic discharge as small as 100 volts or less. Now, when you hear 100 volts, it sounds like a lot. We're used to dealing with 110 volts from our wall outlets, so the smaller DC voltages of 12, 5, or 3.3 volts inside the PC makes a 100 volts sound like a lot. But when we're talking about ESD, an ESD discharge must be about 3000 volts before you can see it or feel it. So when you touch a doorknob and you get a shock, you're dealing with at least 3000 volts. What that means is that you could be working on a PC system and be shocking the daylights out of the components in there and not even know it because the discharge is so small that you can't see or feel it, but it's enough to hurt the components. ESD is bad, but there are a number of steps that you can take to reduce the risk of ESD when you're working on a PC system. First, discharge yourself before you touch any PC component. There's a lot of different ways you can do this, but the easiest way is to simply touch the case frame of the PC system. When you do that, any electrical potential or difference in potential that may have existed between you and the case is immediately discharged. The next thing you can do is to use a static mat that allows you to equalize the electrical potential between you and the PC system. You can also use static floor mats or static floor materials. A static floor mat is designed to keep you in balance with the electrical potential of everything around you. If you've ever walked through a carpeted room, in socks for instance, you know that you will build up an electrical charge. When we use static floor mats or static flooring material, that charge never builds up, and any charge that you may have is immediately dissipated through the mat or through the floor. Also, when you're handling an electrical component out of the computer, like a memory chip or a CPU, don't touch the gold or silver leads on the bottom of the component. Also, on the expansion board card, don't touch the little tab connectors. The reason is, if a static discharge occurs and goes through these leads, then it just traveled right into the heart of that component and probably shorted some circuits, so don't touch the leads. In addition, you should store your components in static shielding bags. If you've ever bought a computer part from a computer store before, then you've probably noticed that the part came in a gray bag. That's a static shielding bag. It has an additional layer built into it underneath the plastic that absorbs electrical discharges as they occur and dissipates them around the component, instead of letting them go through and hurting the component themselves. If you ever purchase a part and it comes in a pink, blue, green, or clear bag, those are static resistant bags. If you see this kind of bag, be extra careful because those bags don't provide the same level of protection against ESD that a static shielding bag does. Also, watch out for static producing materials in your work area. These include plastic and styrofoam. Plastic and styrofoam can build up a great deal of electrical charge in you, which can subsequently shock your components. So keep plastic and styrofoam away from your work area as much as possible. Remember that humidity is your friend when you're dealing with electrostatic discharge. The higher the humidity is, the less likely that an electrostatic discharge will occur. Dry air acts as a resistor and allows static electricity to build up. To keep the static down, you should keep the humidity in your work area relatively high. So let's review. Electrostatic discharge can be a really bad problem because when it happens, you may not even know it has occurred. It only takes a small amount of voltage to ruin a PC component. To keep electrostatic discharges from happening, make sure you use static prevention measures, like using a static mat and a static floor mat. Keep substances that cause static charges, like styrofoam and plastic, away from your work area and increase the humidity in the room to keep the static down. In this lesson, we're going to talk about how to prevent electrostatic discharge, or ESD, while working on a PC system. Remember, an ESD occurs when there's a difference in electrical potential built up between two objects due to a static charge. When you're working on a PC system, this could be a bad thing because a discharge can damage PC components. So you need to make sure that the static charges between you and the case are equalized. To do this, use a static mat. This is a static mat. A static mat equalizes a static charge. A static mat is composed of a conductive surface. This surface you see right here is designed to conduct electricity. If we take an electrical component, such as a piece of memory or a CPU, and set it on this mat, it establishes connectivity between that device and the mat. That way, there's no charge being built up. Any charge that does get built up dissipates between the computer part and the mat, and whatever the mat is connected to. When you're working on a PC system, you need to establish connectivity between the case and the mat and you. What we do first of all is to take the case and use this alligator clip right here to connect or ground a case to the mat. Now we've got connectivity established between the mat and the case, so no difference in static charge can be built up between the mat and the case itself. The next thing you need to do is to ground yourself so you don't build up a static charge either. To ground yourself, use a second clip and connect it to a wristband that has a little metal plate, and we connect that to our wrist. This establishes connectivity between me and the case and between the case and the mat. Now when we set things up this way, there can be no static charge built up between me, the case, or the mat. We're all equalized because the current, anything that does build up, immediately gets dissipated through the system and we stay in equilibrium. Now this brings up a very important point. You need to make sure that this case is unplugged before you start attaching these clips. I'm going to say that again. Before you start attaching the clips, unplug the case because we've got connectivity going on here. You don't want to be connected to 110 volts. Now some people in the industry will try and tell you that it's actually a really good idea to leave this system plugged in while you work on it. They say that because it creates a perfect ground. Now it may be a perfect ground, and I don't know about you, but I don't like the idea of being connected electrically to something that's plugged into the wall. If that power supply were to have a fault or a problem and allowed current to go through the components to which you are grounded, you could get a really nasty shock. And if you can't get this wrist strap off fast enough, you're going to have some problems. So I'll say it again. Please unplug the system before you attach these grounding cables. Old power supplies had a physical switch that broke the current between the wall and the power supply when shut off. New supplies don't do that. Even when the system is turned off, it still supplies a continuous current to the motherboard. So if you had this case here with a power supply and it was plugged in with the system off, you might think you're safe, but you're not because there is still a current going through the system. Granted, on the motherboard side of the power supply, it is DC current, and it probably won't hurt you that much, but if the power supply were to have a fault and was leaking AC current into the system, you would still be in trouble. So as a general rule of thumb, unplug the system before you start using a static mat. That's it for this lesson. Remember that when you're working on a PC system, you need to prevent electrostatic discharge damage. The best way to do that is to invest in a good static mat and to use it properly. Also remember to unplug the system while you're working on it. You don't want to be hooked up to that 110 volts through a static mat.
(2.1.5) ESD FACS electrostatic discharge. ESD, static electricity is the accumulation of a friction-caused electric charge on a non-grounded object. The static charge on the surface of a non-grounded object can jump when it contacts the surface of any grounded object. This electric discharge is known as electrostatic discharge, ESD. ESD can be very destructive to a computer. The threat of ESD begins when the fragile components, including the processor, hard drives, memory, motherboard, and expansion cards, inside the computer are exposed. You can cause damage simply by placing a fingertip too close to a component inside an open computer case. ESD charges can travel through wires and into components, where the wires can explode or fuse together, causing the components to fail. ESD can cause immediate failure of components or could gradually degrade components, causing only intermittent problems. It takes very little ESD to damage a component. A discharge of as little as 10 volts can damage a component, but 3000 volts or more of ESD must occur before you can even feel it. ESD safety measures implement the following measures to defend components from ESD. Keep the relative humidity in the room at an ideal range of 35 to 70%, and temperature between 72 to 77 degrees. The key is to avoid dry air in the computer repair location to prevent ESD. Use anti-static mats under the PC and on the floor. Discharge yourself before touching any computer component. When touching anything inside the computer, wear an anti-static wrist strap that is attached to the metal PC chassis with an alligator clip. Ground both yourself and the computer to the same ground. This provides a single path for the flow of electrical potential. Use static-resistant materials to handle computer components. Never touch the metal connectors on a circuit board. Keep the computer repair location free of materials that accumulate electric charges, such as plastic and styrofoam. Store sensitive components in static shielding bags, which are usually gray. Static-resistant bags are not nearly as effective. They are usually tinted pink or blue. Unplug the system before working on internal components. Do not rely on the power cord for an electrical ground. 2.1.6 Practice questions. Explanation. Before you begin any internal service on a computer, you must always be sure that the computer is completely disconnected from the power source. Not removing power can lead to serious harm or death. After the power is disconnected, you should remove any jewelry. Doing this eliminates the possibility of accidentally getting any electronic discharges. Placing the computer on an ESD mat and using safety glasses would also be beneficial, but the first thing you should do is disconnect power. Explanation. The third, or middle, prong of a computer plug is the grounding prong. In the event of a malfunction, the electricity flows through the grounding prong to the earth, which, in turn, trips off the breaker, removing all electricity from that outlet. If the grounding prong is removed or bypassed and a malfunction occurs, the electricity will find the next shortest path to the earth, which may be a person who touches the computer. Having the electricity pass through a person could cause serious harm or even death. You should never remove the third grounding prong or use an adapter to bypass the prong. Explanation. Do not use an ESD wrist strap when working with monitors, power supplies, laptop LCD panels, or other high-voltage components. If you wear jewelry when working with hardware components, you need to be careful as it can conduct electricity and cause physical harm. However, using an ESD wrist strap is designed to protect hardware components and does not impact personal safety. An ESD wrist strap protects hardware components and has no impact on personal safety when replacing worn or frayed power cords. An ESD wrist strap is specifically designed to protect memory modules from electrostatic discharge when replacing memory modules in a computer. Explanation. Material safety data sheets, MSDS, are written and distributed by chemical manufacturers. You can download them from the manufacturer's website or request them from a company representative. MSDS sheets contain information that is only available from the manufacturer. Neither your manager or a workers' safety insurance office can provide MSDS documents. Attempting to write your own MSDS sheet can be dangerous, as you do not have all the critical information necessary that is available from the manufacturer. Explanation: A cathode ray tube, CRT, monitor can store large amounts of electricity, even when unplugged. You should never open a CRT monitor, as the capacitors within the CRT can store enough electricity to be lethal. LCD monitors do not use large capacitors and are much safer to work on than CRT monitors, although the CCFL backlight has mercury vapor in it, which could be harmful if the tube is broken. DVD optical drives and hard disk drives do not store electricity in sufficient quantity to be harmful. Explanation: using short bursts of compressed air to clean delicate components, followed by using a special vacuum designed to remove dust from all components, provides a safe procedure for removing accumulated dust. Removing the power supply to clean it outside of the case can cause personal safety issues, as the capacitor in the power supply can still hold an electrical charge. Using a continuous stream of compressed air to clean all components can cause dust to blow into other components and even into the office, which can then accumulate in other electrical devices. Using a cleaning solvent can cause serious damage to hardware components, especially if it comes in contact with electrical connections. Explanation: fiber optic cabling is totally immune to ME and provides the highest level of ME protection. Coaxial cabling is highly resistant to ME, but is not as good as fiber optic cabling. Due to the number of twists, Cat7 cabling provides better protection from ME than Cat5e cabling. Cat7 can also be procured with added ME shielding. However, Cat7, with or without shielding, is not as good as fiber optic cabling. Cat5e provides good protection from ME, but Cat7, coaxial, and fiber optic cabling provide better protection. Explanation: to be felt, an ESD charge has to reach the level of approximately 3000 volts. Some computer components can be destroyed by discharges as low as 20 or 30 volts. Explanation: walking across a room, especially on carpet, will generate static electricity on your person. Discharging this electricity to a computer component may damage that component. Under these circumstances, it is best to use an electrostatic discharge (ESD) wrist strap to ensure proper grounding. An ESD heel strap only works if the surface the technician is walking on is ESD protected. Since this room has nothing but carpet, heel straps would be ineffective. ESD mats neutralize the static buildup between the computer and mat, but it is still best if you connect yourself to the computer via an ESD wrist strap. Otherwise, the static electricity you gain by walking across the floor can still be discharged to a computer component you touch. Although self-grounding is good, the fact that you are working on carpet means that additional static may build up if you shuffle your feet while working. Explanation: when using an anti-static wrist strap, you should connect the wrist strap to yourself and the other end to a ground such as the clip on the anti-static mat, or to an area on the computer case so that you and the computer are at the same electrical potential. Never connect the wrist strap to a power outlet, power supply, or ground on a power source.